Computers are useless. They only give you answers. Probably not what you expected to hear at a conference about a computer software program. But there's wisdom in the words of Pablo Picasso. Answers are not enough. It is questions that lie at the heart of our quest for understanding. My name is Ross Bunker. I'm a principal software engineer at Tableau. And today, I want to focus in on questions. Tableau is all about helping people see and understand data, helping you see and understand your data. And we talk about answering questions a lot, and the visualizations that Tableau presents are how we show you the answers to your questions for your data. But the questions sometimes get lost. And one of the really important concepts when it comes to the questions you're asking of your data is level of detail. So today, I want to go through a few things. I want to first talk about why questions matter and why level of detail is important to those questions. Next, we'll talk a little bit about what level of detail really means. And not just in an abstract way, but in very concrete terms. A bunch of our time will be spent looking at the history of features in Tableau and how level of detail presents itself within those, and how each of those features lets you answer different types of questions. And at the end, I'll spend a little bit of time talking about the future and what we're trying to do at Tableau to help enable you to answer more questions with your data. Now, when we think about data science, we often have a somewhat rosier view of our role than the reality. This is a wonderful image that Dr. Roger Peng put on his blog about better questions in data science. And, we often think that we have the right question and we just need to find the data to prove and demonstrate the answer. But the reality is that the quest of the data scientist oftentimes is as much about finding the right question and making our questions better as it is about finding answers. And questions are so important. If you do not know how to ask the right question, you discover nothing. A quote from W. Edwards Deming, a famous civil engineer and one of the pioneers of business process and using data to drive business decisions. This is a great quote. There's an even better quote. If Tableau does not let you ask the right question, you discover nothing. I prefer this quote because I made it up. But really, when it comes to Tableau, if we can't help you answer, if you can't ask the questions of your data that you need to, what good is Tableau doing? How can we show you an answer to that question if you can't use Tableau to ask it? So when we think about asking questions and seeing answers in Tableau, there's a couple of things that come to mind. But let's just take a look at a visualization here and try to understand, given the visualization, what is the question? So what you see here is, and it may be hard for some of you to read in the back of the room. They're big screens, but not quite that big. We've got product on columns, we've got sum of sales on rows, and then we've got product type on color. And so what we're seeing here is sales for each of our products, and then it's broken down by product type on color, so we can see how those relate. So what are the total sales of each product, and help me see by product type too. Simple question, pretty simple answer, no problem. Let's take another example. So again, looking at the fields that we have on the shelves here in Tableau, we've got call center region, and we've got a bunch of measures. Count of employees, total employee salary, and then we divide the two. So it looks like we're trying to figure out, for the call center regions, how much are we paying on average each of our employees? And if you look at these numbers, they might seem a little out of whack. $3.5 million per employee. Yeah, I want to work there too. Tableau pays well, but I guess call center regions is where it's at, or call centers is where it's at. Somehow I think not. So what's going on here? So what's happening here is the replication problem, and you saw a little bit of this today in the Devs on Stage keynote, and I'll talk a little bit about that later. But let's try to understand what's happening. So if we drill down to a single employee, Chris Abe, earning $1.7 million, it would seem. Again, would like to be Chris. If we drill into the underlying data, we can see what's happening is here we see Chris and his salary, but it's being replicated, right? We've joined the employee data, which is about employees, with the sales data, which is about products. And because an employee sells multiple products, we get this duplication, and when we add up all those numbers, we get the wrong number, right? So this is what's going on. So the problem there is a mismatch between the level of detail of the data and the question we're asking. But let's take a step back and ask what LOD is. Now, we could talk about LOD in a bunch of ways. We could talk about it in terms of dimensions. We could talk about it in terms of grouping fields in SQL queries. But I'd like to step up and really get concrete with it, right? Because data comes from the real world. It isn't just made up unless you're really creative. So here is a purchase order. Purchase order is a pretty common piece of business information, and it's got a lot of pieces of data associated with it, right? We've got salespeople. We have producers that make the products that we're selling. We have the purchaser, the person who's actually making the purchase. We have the products that are being sold. We have the company, but there's actually multiple companies, right? We have companies for the producers, the sellers, the middle person who's actually completing the purchase order. We have the states, but again, there's multiple states. There's the salesperson's state. There's one for the purchaser. There's one for the producer. And we have time. We have order dates. We also have ship dates, although those aren't pictured. Right? So we have all these different elements in this purchase order. What are the kind of questions we might ask of this purchase order data? Well, I could ask about total sales by date, in which case I'm going to look at the sales information, the prices, and I'm going to look at the date. We could ask about the number of products, of a specific product sold, and look at the quantities and the product types. We could look at the highest volume producers in a given state. We could look at zip codes and which ones had the most purchases. And so all of these questions have kind of this common pattern, right? For this given set of characteristics of these things, right, the states of my producers, the names of my products, what is my measurement? What is my number sold? What is my total sales amount? So I define level of detail to mean the set of characteristics that you use to define the things you're measuring. And when it comes to asking questions of your data, figuring out what things are in your data that you can ask questions about and what measurements you want to use to define the elements of your question is really the fundamental thing that has to happen. So this is a visualization, not made in Tableau, obviously, that our esteemed sales consultant extraordinaire, Alan Eldridge, made to help describe level of detail to some of his customers. And I appropriated it for this talk. And I'm going to use it as we look through the features of Tableau to help really make concrete and visual what we're talking about when we talk about level of detail. Now, this diagram is interesting for a couple of reasons. The key elements here are, at the bottom we have what we think of as totally disaggregated data. That is, data, the raw rows of your input data. And at the top we have what we think of as totally aggregated data. So if we add up all of the sales to one number, that's what we get at the top. And so as we move up, we're aggregating more, and as we move down, we're getting more and more granular with the data. And the reason it's drawn this way, we could draw it one of two ways. We could draw it this way, top down. We could also draw it where the totally disaggregated stuff is at the top, and we get more and more specific as we go down. But I've drawn it this way with the arrows this way, because this is what it's like in Tableau. When you start in Tableau and you drag out a measure, you get one number. And as you drag out more and more dimensions, right, that number gets broken down into smaller numbers, but there are more of them. And so that's what this image sort of mirrors, is this act of dragging dimensions out in Tableau. Now, I want to also talk a little bit about aggregation. Now, when I did a Google search for aggregate, this is what came up. And I looked at it for a minute, but I realized it's actually not that inaccurate, right? Aggregation is this process of taking small, fine things in your data, the rows, and putting them together to create larger and larger chunks. And if we look at the visualization again, aggregation is what lets you sort of move between these levels of detail. We start off at the bottom at the row level, and we can move up by aggregating, by grouping and creating, summing our numbers, averaging our numbers, et cetera. We have big numbers at the top, big boulders. As we drill down, we get smaller but more of them. And at the very bottom, we have this big pile of data. So it's a pretty useful way of thinking about level of detail and aggregation. So now let's talk about Tableau. So the first thing that you run into with Tableau is your data source's level of detail, right? The Tableau data model today, and again, I'll talk about some of the new features a little later, exposes a single flat table. And that flat table is this bottom of the picture. It's all of the rows of your data. And so that's when you connect to data and you look at the bottom pane in the data source pane, that's what you're seeing, all of the rows of your data. But the next, and this is a representation of that table. But the next level of detail that's really important is the viz LOD. And this is sort of the fundamental level of detail that you have in Tableau. So the viz LOD represents the level of detail of the data that you see in your visualization for the most part. And you get there by dragging out dimensions and dragging out a measure or two and seeing the answer. And almost all of the other levels of detail in Tableau relate to the viz level of detail. So it's a really important one to understand. So what kind of questions do we ask with viz LOD? Right, so I'm just going back to the first picture I showed. This is one of the most fundamental types of visualizations you have in Tableau. Total sales of each product, help me see by product type 2. You can see I've got my sum of sales out there as my number. I've broken it down by product and product type. Pretty straightforward. Nice, simple question, nice, simple answer. But Tableau lets you access other levels of detail, and they can make your questions richer and your answers more complicated, but also more useful. So the next level of detail I want to talk about is the summary LOD. So features in Tableau that let you access the summary LOD include totals, reference lines, table calculations. And the summary LOD lets you take data at the viz LOD and summarize it, creating aggregations from the viz LOD up to the summary LOD, but the viz LOD is still there. And so you can then compare the two. So here's an example of that. So again, we have products and product types, but we've added a reference line. And this reference line is showing the average sales across all the products. So it's interesting to see how your individual product sales compare to the average. You can see which ones are above and which ones are below. But there's a lot going on here that may not be obvious. For one thing, this average number is not the average of my underlying row data. If I look at the average of my underlying row data, if I change that sum of sales to average sales in the green pill, you can see the numbers here, or you may not be able to, but I will tell you the numbers here are between 100 and 300 units. And you can see the average is a little over or a little under 200. So what's happening when we actually have the sum of sales there is we're summing everything into this 50 to 200,000 range. Then we're averaging from there. So we're not averaging the underlying data, we're averaging the bars that are already in the visualization. This may not seem miraculous, but you're defining a new level of detail with your viz that you're then able to aggregate from there. So you're doing two levels of aggregation. You're first summing to the viz LOD and then averaging from there. And it's powerful. It lets you ask these questions that you can't ask of the raw data. So the next level of detail I want to talk about is the filter level of detail. So filtering in Tableau lets you access a number of things. The simplest ways you filter are you get rid of marks by saying, oh, I don't want to see this product or that product, or I only want to see things over this amount. But when you access some of the other tabs in the filter dialog in Tableau, you're actually doing level of detail calculations. For example, if you want to eliminate products from the visualization that have a total lifetime sales of more than 40,000, you can do that with a filter. And it doesn't matter what the viz LOD is. The viz LOD has nothing to do with the filter that you place there. Because what happens is we take the product, we compute a sum of sales for each product across all of the rows of the data, we find the ones over 40,000, and we keep those. So here's a visualization that uses such a filter, and it asks a question, or it answers a question: how do sales of products fluctuate over time for products with lifetime sales more than 40,000? Now, you can't really see the 40,000 in here anywhere. It's in the filter. But it's pretty clear that none of the numbers here are more than 40,000, right? So that 40,000 came from somewhere else. That 40,000 came from summing the products over all time, not for each month. And so you're accessing two different levels of detail in asking this question. And so all filters, when you build them and you access the limits and conditions inside of the filter dialog, are acting at the level of detail of the dimensions that you're filtering on, and no others. Doesn't matter what your viz LOD is. It doesn't matter what other LODs are in play. Now, I'll also mention that sets are basically another way of defining filters that are named, and then you can use those in calculations and other things, as you saw in Devs on Stage today. And I'll talk a little bit more about those as well. Okay, so let's shift gears a little bit and talk about a different type of level of detail. So extracts are a feature of Tableau that people usually use to help with performance. Extracting data to a more performant database, offloading work from a transactional processing system into Tableau's Hyper so that you can get faster response times or minimize the impact to your other systems. But extracts have a little known feature in them that lets you actually change the LOD of your data. When you create an extract, you can specify a different LOD, in particular with respect to time, that will let you ask different questions of your data than you would be able to ask otherwise. What does that look like? So here I have a question I want to ask. What are my average monthly sales for each year and quarter? So I put quarter in a continuous form out on the viz, and I put the average sales. Looks like the question I'm asking. But if you look here, the numbers are between 1,500 and 2,000. And if we actually drill down to the day level, you can see that this is actually daily averages, not monthly averages, right? So I'm selling about 1,500 to 2,000 a day, and when I look at that quarter, I'm looking at the quarter level. So really, I want to actually sum the data to the month level so that I can have my monthly sales. That would look like this. And you can see the numbers are kind of between 1 million and 1.5 million-ish. So how can I get the average of this? Well, I could put a reference line out there, but the reference line is just going to show me the average for the whole thing, not for every quarter. So, extract LOD to the rescue. When we pull up the extract dialog, we have this option in the middle of the screen to aggregate all the measures and roll them up. And we can roll them up to the month level. Now, when I compute my average, I'm actually computing the average of the monthly data. And so you can see here the numbers are again in that 1 million range, but I've got an average out there, and I'm at the quarter level, so I've smoothed out those months. 3 months are contributing to each quarter in an average. So I've basically been able to change the question I could ask by using the extract LOD. So one of the next features we added to Tableau was geospatial, geocoding. Now, geocoding is a little different than a lot of the features we've talked about before. The features before were talking about manipulating the LOD of your base data source. Here what we're doing is we're actually bringing in external data, but we're bringing that data in at a specific level of detail. We're bringing that data in at the level of detail of our geographic fields. And those geographic fields may not be at the viz LOD. I may have multiple marks. I may have multiple pieces of data for each geographic entity. And geocoding doesn't care. Geocoding says, you got states? I'll bring in a latitude and longitude for each state, even if there's multiple occurrences of that state, right? So that lets me ask questions like this. Sum of sales in each state, and how does it vary by product type? The one and only approved use of pie charts in the universe, pies on maps. So now the interesting thing here, right, is that every state has 4 product types. A couple have 3. But geocoding doesn't care. Geocoding just says, you got a state. I'll throw in your latitude and longitude. Tableau knows, I've got 4 things here. I'm going to put them all in a pie. So takes that idea, lets you join at the LOD of the states, and there you go. So that was cool. Everybody loves mapping. But it turns out that there's an analog. We can not only bring in data from geospatial information to do geocoding, we can actually bring in data from anywhere and basically do the same thing. And this gave rise to data blending. So in data blending, I have 2 data sources. I have a main data source, which I use to define the viz LOD, and I have another data source that has some contextual information that is valuable. And what we can do now is, whereas geocoding data is generally at a particular LOD, be it states or regions or zip codes, this external data could be at any arbitrary LOD. And what I want to do is bring it into my visualization based on the fields in my visualization at a particular LOD. And so what we do is we actually take that data, whatever LOD it's at, we aggregate it to the LOD that we need to bring it in, and we bring it in and put it in the visualization. This lets us answer even more questions. How are my regional sales doing versus quota? Again, looks like a simple question. The complexity is in my data. My data, sadly, does not have quota information in the sales database, right? So how do I get it in there? Blending to the rescue. Here I've got my quota data. It's quarterly, not yearly. But I have for each market how much sales I want in each quarter. So the way blending works, we say I have year and market in my visualization. So we're going to aggregate my sales in the quota spreadsheet to get rid of quarter and add those up. And then I'm able to have this visualization. I have market and year, so I can bring the data together. And I have the light bars, which are my quotas, and my dark bars, which show my actuals. So blending lets me answer these new set of questions which involve multiple data sources and a particular level of detail that I want to bring them together at. Well, this is great. This lets me answer all kinds of new questions. We probably don't need to add any more features to Tableau at this point. well, not quite. Probably a week later, customers came back and said, well, I have other cases here. I have other situations. So down the road, we released an updated version of data blending that lets you actually join data not at the viz LOD or not at things in the viz LOD. So we can actually, in Tableau, join data below the viz LOD at more granularity on dimensions that aren't in your viz, and then take that data and aggregate it to the viz LOD. What kind of questions does that let me answer? So here again, we have profitability and sales territory. Again, looks like a simple question, looks like a simple viz. Under the covers, though, what's happening? Well, again, I'm faced with the situation that my data doesn't have sales territory information in it. So what I want to do is take the sales territory information, which is by state, and combine it with my sales data, which is also by state. But I don't want state in my visualization. Data blending lets me do that. I can bring that data together at the state level, aggregate the remaining sums together for each territory in order to get the sums here. So everything we've looked up to now has been related to viz LOD. Somehow, one way or another, above it, below it, that sort of thing. LOD calculations, released in Tableau 9, are basically the way that you can access level of detail independent of the visualization. LOD expressions come in a couple of flavors. We have fixed, we have include and exclude, and there are deeper talks that will go more into LOD calculations and all the awesome ways you can use them. I'll talk a little bit here about why they behave the way they do. So fundamentally, fixed LOD calculations exist independent of the viz. They're like these little blue marks here. I can define a set of numbers relative to a set of dimensions, and then I can bring those in. Because we know the level of detail that that calculation is defined at, I can bring that into my data. And I can bring it in two different ways. If I'm using that LOD calculation as a dimension, I can bring it in at the row level, so I make it part of that row level data, and then I can aggregate using it. I can make it one of the levels of detail that matter. And that's super powerful. But the other way you can bring in LOD information is at a different level of detail. Specifically, you can bring it in at a level of detail that avoids the replication problem, right? If I bring something in, if I bring a number in at the row LOD, it's going to be replicated possibly across all of the other dimensions which aren't part of that fixed LOD calculation. So by bringing that level of detail calculation in at a higher level, where there isn't going to be replication, I can avoid those problems of having numbers repeated and skewing my data. So, quick example of a question we can answer with LOD calculations. Does the month in which a customer makes an initial purchase affect their long-term spend? So, again, seems like a simple question, except again for the data. The LOD of my data does not include a purchase, an initial purchase value for each customer. LOD calcs to the rescue. So, here we have an LOD calculation. For each customer, I want to compute the min order date that's in my data. So, we now have this piece of information, the first order date that every customer had. I can now attach that to the customer in my original data. And so in my original data, I now have this piece of information for every customer. And so if I want to group customers by the month in which they made their first purchase, I can add up all of their purchases. And I can now have this question answered. So we've looked at a bunch of features, and we've looked at the types of questions that those features let you ask. One of the biggest things I want people to take away from this is the fact that asking questions often requires multiple levels of detail. The simple questions are easy. It's the complicated ones that involve multiple levels of detail that require you to access different features of Tableau and combine them in ways that enable you to ask the question that you want. So one of the early papers that Tableau put out from our research group was titled "There is no single view." And it was Jock McKinley, one of the pioneers in visualization, who joined Tableau early, and our founder, Chris Stolte. And it talks about how one of the great values that Tableau brings is the fact that you can move fluidly between different types of visualizations. And this was a really great insight, and it really highlights the value of Tableau. Now, another thing I think highlights the value of Tableau is that there is no single LOD. Again, I'm partial to this one. And it's really important because all of the features of Tableau really are working together to let you create the questions that you need for your data. And there is no single LOD that will answer all of your questions. So I've talked about a lot of these things, but there's still a lot of questions in Tableau that are hard to answer. Sadly, we're not done writing features, which is good for me because it means I still have a job. One here is employee sales to salary ratio, right? So this is, again, the example we talked about. We saw a little bit of this in the devs on stage as well. But when the LOD of your data when your data contains multiple levels of detail baked into it, you have to use LOD calculations in order to, unreplicate that information and figure out how to do it. So it's feasible today, but it's still kind of cumbersome. Another example is, what about employees that have no sales in some months, right? If my data is at the sales LOD, months where there were no sales for a particular employee are hard to pick out. Another example is geographic, the relationship between customers and stores. Now again, the buffering features you may have seen in Devs on Stage this morning help with this, but fundamentally, I don't want to have to join my store's data to my customer's data in order to make this work, because then, my customers are going to be associated with a particular store, and really I want to be able to see both of them on a map together without having to join them, without having to associate one customer with one store, or worse, a customer with multiple stores. How many stores? So this is another thing that's still hard to ask of Tableau today. Another thing is doing ranking, right? So you can do things with top 10s and things like that in Tableau, and you can use table calculations to do this specific thing. But because table calculations live at the viz LOD, you have to bring in a whole bunch of data, do your table calculations, and then sometimes you need to actually throw some of that data away. You have to build filters to hide some of the table calculation data, and it gets very messy. So it would be great if we could write these calculations like LOD calculations, where they're independent of the visualization. So what are we doing at Tableau to help address some of these? So the first thing I'll talk about is relationships, the new Tableau data model. So you saw this demo this morning at Devs on Stage, I hope. How many people saw that? Yeah? How many people are excited about that? All right, long live the noodle. But the fundamental thing going on here is that today, Tableau thinks of your data source as a single LOD, right? If you have joined your sales data to your employees' data, and you have employee salaries, it thinks, as far as it knows, that that employee salary is for every single row. So what the new data model enables is the ability for a single data source to know about multiple levels of detail and to keep track of them. So when I talked about fixed LOD calculations, I talked about how in the fixed LOD calculation, we know, because of the fixed expression, what the LOD of that calculation is. We know how it was computed. Because of that, we know where to join it in the process to avoid the replication. That's exactly what we can do now with the new data model. Instead of modeling joins, we model relationships. We then leave flexibility for us to be able to aggregate and bring data in at the right level of detail, given the visualization, in order to produce the numbers that you expect. So one of the great things is that a single data source can now answer a lot more questions. Instead of having to have a separate employee data source and a sales data source to ask employee questions of the employee data source and sales questions of the sales data source, you can now use a single data source to answer lots of different questions. So what's coming up next? So we saw a little bit with the buffers, the ability to combine data at different LODs using spatial joins. But as I mentioned, that still requires you to connect those pieces of data together. One of the things we're working on is the ability to be able to overlay information. So there is no join going on per se, but we're merely able to see data together on timelines, on spatial maps that are related in that way, not in a direct data way. And that's very powerful and will help answer other sets of questions. The other thing is this idea of being able to do calculations at LODs that currently you can only do at VisLOD, table calculations, forecasting, and all of these other types of operations, but being able to do them independent of the visualization. So then you can do your computations where they need to happen without having to bring the data into Tableau. And then again, because we'll know what the LOD of those computations is, we can bring them into Tableau at the appropriate place and avoid the replication issues. So the fundamental thing I want to leave you with is that thinking is not driven by answers, but by questions. The questions we ask are the fundamental thing that Tableau is trying to help you with. Seeing answers to the questions in your data. And understanding the level of detail of your data and the level of detail of your question and how your question's levels of detail manifest in Tableau is a really important part of this process. So as you come with, one of the things I love about Tableau Conference is I get to hear about all the ways that we still can't answer questions. I go to Tableau Doctor, go to the showcase. It's opportunities for people to let me know what the questions are we're still not answering. And I look forward to those every year because they really inspire me to help figure out what the next set of things we need to do are. On the subject of learning, I wanted to point out a couple of other talks, Loads of Fun with a Level of Details, which is tomorrow, and the Ready, Set, Go, Set, and Set Actions, which are later today. Both valuable talks to get more insight into how you can ask richer and richer questions with these features in Tableau. That's really all I have to say. Please fill out the session survey. We love the feedback. We'd like to know how we can make our talks better. And I'm happy to stay up here and answer some questions. I don't know that we really have mics, so if you want to come up to the front, I'm happy to answer, and I'll try to repeat questions and give everybody info. Thanks very much for coming.